Hey guys, we're going to talk about synthetic division now. So again, I'm going back to an example that we've done, and that was the original polynomial for long division, dividing it by a factor of that polynomial. We can tell it is a factor because we get a zero as a remainder. And what I've done is I've gone through and I've color coded each one of my terms in that polynomial. And again, my orange negative signs is because each time that I go through I'm subtracting, so that causes the signs to flip. And once I flip the signs to the opposite sign, then I add them together. Okay, so over here, look at what we've done. We've just removed coefficients. The variables, and all we have left are the coefficients, and they're the same color, so red, purple, orange, blue, and green. And it shows you that you work it out and you can have the same thing by removing the variables. But we can refine this even more, because with synthetic division it is a faster method. It avoids duplication and extra writing. The one thing to remember is that the divisor that you're going to divide with is the value of x that you're looking at. So in this problem where I had x plus 2, what I'm going to have to divide by is a negative 2. And the reason is I set that binomial equal to 0. So x plus 2 equals 0, and then I solve for x. X equals a negative 2. So let's look at synthetic division. Alright, a little busy here with my diagram. So here's our original problem that we had all the way back with long division. This is my given polynomial, and what I want to do is divide it by this binomial. So again, what I just talked about, I'm going to divide by negative 2. What I do is I remove each one of my variables, but before I do that I need to make sure that my polynomial is written in descending degree order. So fourth, third, second, first, 0, and that's what the red numbers above it illustrate. Fourth power, third, second, first, 0. Again, x to the 0 is simply 1, so negative 20 times 1. This is considered to be to the first power. We just don't write a 1 with it. And here are all my powers, and what I do is I plug in a coefficient, or the coefficient that's with, or that's in each term. Okay, so this was a 1, it's understood 1 there, there's a negative 6, there's an understood 1 there, 24, negative 20. Now I have everything written out. If I were not to have a descending order, I rewrite it to where there is. If there's a gap, if there's a term missing as far as the power, say x to the third was missing, I simply plug in a 0 times x to the third. I have to fill that gap. And 0 times anything is 0, so I'm not really changing my polynomial by putting it there. I'm writing something extra that can just generally be omitted. But for this, I need all those place values. I need everything in its right spot. So the first thing that I do is my problem, and I'll write it out here, is that this is how my problem initially looks. 1, negative 6, plus 1, plus 24, minus 20. And then I drop that 1 down. So step 1, it's written in green. Bring down the lead coefficient, in this case it's 1, and multiply it by a negative 2. So I say negative 2 times 1. And then for step 2, I'm going to write my negative 2 up there. I write the product of 1 and a negative 2. And then I just do the math, I add them together. A negative 6 plus a negative 2 is a negative 8. See, step 3, I sum negative 6 and negative 8. And then I kind of repeat. I'm going to say a negative 2 times a negative 8, and this is step 4. I multiply a negative 2 and a negative 8, and I write the product. Negative 2 2 times the negative 8 is 16. Do the math, just add them together. We're not worrying about flipping signs or anything. Whatever that product is, we add it to whatever's up there. Gives me 17. I repeat this same procedure all the way to the end. So I say a negative 2 times 17 is a negative 34. Add the two together, it's a negative 10. A negative 2 times a negative 10, that's 20. Sum them together, value of 0. And we already knew this from a prior example. Again, this is the value of the function at x equals a negative 2, or how we can have it written x plus 2. So, that is synthetic division. What I'm going to do up here is I will work it again, what we just did. So I say a negative 2 times 1, that's a negative 2. Add them together. Negative 8. Negative 2 times a negative 8, 16. Add them together. Negative 2 times 17, negative 34. Add them together. Negative 2 times a negative 10, 20. Add them together. That is synthetic division. Okay, so I have a problem for us to work. We're going to use synthetic division to find the quotient and the remainder. And the remainder can be 0 also. So we're going to use synthetic division to do this. First thing I turn around and do is that I know I'm going to divide by 3. And then I'm going to work through here. Notice I'm missing x to the 4th and x squared and a constant. So I'm just going to plug those in with zeros. And what I will do for the zeros is write them in a color that stands out. How about red? Okay, so 1, 0. Now I'm at x to the 3rd, 1. And now I'm at x squared, so 0. And a negative 1, I'm at the 1st. And now I'm at the constant, or x to the 0, I'm at 0. And to illustrate, 5, 4, these are the powers, 3, 2, 1, 0. I now have everything set up. Now I'm left doing my synthetic division. I drop my 1, 3 times 1 is 3, add them together, that's 3. 3 times 3 is 9, add them together, that's 10. 3 times 10 is 30, add them together, that's 30. I should have gave myself more room. 3 times 30 is 90, add them together, that's 89. And then 3 times 89 is 267, right? 27, yep, 267. So what this actually looks like, because each one of these are individual terms, and I'm going to put them with their variable. I know I start off at x to the 4th, right? Not to the 5th. So I have x to the 4th, and I'll write the coefficient there even if it's a 1, plus 3x to the 3rd, plus 10x squared, plus 30x, plus 89, right? With the remainder of 267. This is my quotient. Again, I can get rid of that 1. We understand that it's there. This is my quotient, the answer to the division problem, and this is the remainder. Let's do one other problem. The example says use synthetic division to find the function value. Okay. Remember, descending exponential order whenever you write it, and if there's any gaps, you fill them in with the 0. Okay. And the remainder is the value at that x. So if I'm going to find f of 1, then I say I am dividing by, and they give it to me, they give me x. Okay, so I'm just plugging in a 1. So I have 1, a negative 6, 11, and minus 6. So 1 times 1 is 1. 1 times a negative 5 is a negative 5. 1 times 6 is 6. again, we had, I'm sorry, I should write my powers up here. I'll write them in red. This was 3, 2, 1, 0. So my answer is, I'm going to start with x squared. X squared minus 5x plus 6. My function value at f of 1 is equal to 0. What I know is that x minus 1 is a factor of this polynomial. It is a 0. All of this is what I know from what I just did with synthetic division. Now let me find the f of a negative 2 and see what the function value is for it. And I know it's the same thing. And again, this was 3, 2, 1, 0. I have a remainder of 60, and what I'm looking at is x squared minus 8x plus 27, and whenever f is a negative 2, my function value is a negative 60. And again, that is x of x plus 2. And it is not a factor to that polynomial. That is the information taken away. Okay guys, that is synthetic division. As you can tell, it is a lot quicker to perform. Please watch your publisher's videos, structure and critically think about your problems, and good luck with your homework.